Okay, so yesterday we learned about the four quantum numbers, and remember I related the quantum numbers to the way that we could find the address of an electron. It takes four quantum numbers to locate one electron. And what we learned about yesterday was how to find N, L, M, and S. So I want to quickly review over that, and you might want to get your periodic table out that I gave you yesterday to fill in a couple of other little patterns here as we recap. So yesterday we talked about N. N is your energy level quantum number, and N is equal to your period on the periodic table. So the first quantum number, the principal quantum number, can go from 1 to 7. Here, 1, 2, 3, 4, 5, 6, 7 in the S block. The P block, 2, 3, 4, 5, 6, and 7. The D block, 3, 4, 5, and 6. And in the F block, 4 and 5. Now, remember also the S, P, D, and F block. These are regions on the periodic table where we can look to see what the shape of the orbital would be. So the second quantum number was the L quantum number, and we can tell L based on the shape. So in the S block, we said that L is always equal to 0, because if you were to trace a sphere, you'd have a 0 that you would have drawn. For the P block, the L quantum number is always equal to 1. And I remember that it takes one of the peanut shapes here to make the p orbital. So L is always 1. There's one peanut shape. To make the d orbital, we had to put 2 of the peanut shapes together. So L is equal to 2. And for the F block, we had to put 3 of them together to get that flower-shaped orbital. So here L is equal to 3. So that is the N quantum number and the L quantum number real quickly. Now, the two things we did not write down yesterday were the patterns for M and S. I did show y'all how to draw the orbital notation, and that is important to be able to draw the boxes and then fill your boxes in. But I'm going to show you right now how you can also find the M and S quantum number by just looking at the pattern on the periodic table. The first thing you want to do is look at each block. Now remember, we learned yesterday for the S block that for the S orbital, you could draw one box. We call those boxes subshells. So for the S orbital, if you look at the S block on the periodic table, if you take the S block and count how many columns there are, 1, 2 columns, if you cut it in half, then that will allow you to figure out the halfway point, which separates your wives from your husbands, is what we called them yesterday. So half of 2 is 1. Remember, for the S, we could draw one box, and we always numbered that box 0 yesterday. So I'm going to show you how to not have to draw the boxes here in a second. For the P block, count across 1, 2, 3, 4, 5, 6. Remember yesterday we said for the P's, we could always draw 3 boxes, 1, 2, 3. And they were always numbered from negative L to positive L, so negative 1, 0, 1. These are our M numbers that we learned. Well, half of 1, 2, 3, 4, 5, 6 is 3. So if you go to your halfway point here and kind of draw a little squiggly line, okay? The wives are the first half of each block, and the husbands are the last half. For the D block, count over 5 because we drew 5 boxes for the D's yesterday. And remember, we numbered them from negative L to positive L, negative 2, negative 1, 0, 1, and 2. So 1, 2, 3, 4, 5. There's your halfway point. And for the F's, we said we could draw a total of 7 boxes. For the F's, 1, 2, 3, 4, 5, 6. So negative 3, negative 2, negative 1, 0, 1, 2, and 3. 7 boxes, so count over 7. 1, 2, 3, 4, 5, 6, 7. If you notice what I've done here is I've split each block up. And if you count on one half of each block, just look at your D block for a second. 1, 2, 3, 4, 5. Those are the 5 boxes we drew. Okay, there's the 1 box we drew for the S. There's the 3 boxes for the P, and there's the 7 boxes for the F's. So the spin quantum number, to find it, you just have to remember the wives always came home first. So these are our up arrows, up, up, up. And then the husbands come home, down, down, down. Here, up, 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 down, 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 down. So how does that help us find the spin quantum number? Well, the first half of every block, the spin quantum number is equal to positive 1/2. And the last half of every block, the spin quantum number is negative 1/2. And you do need to put the positive and the negative. Here in the F block, S is positive 1/2 for the first 7. S is negative 1/2 for the last 7. For the D block, S is positive 1/2 for the first 5. S is negative 1/2 for the last 5. Positive 1/2 for the alkali metals and hydrogen, and negative 1/2 for helium and the alkaline earth metals. So that's your S quantum number. All right, the M quantum number, that was the mailbox number. When we numbered our boxes, like here, box number 0, negative 1, 0, 1, negative 2, negative 1, 0, 1, 2. When we numbered those boxes yesterday, we call those the mailboxes. That's the M quantum number. It tells you the position in space. So I'm going to number here the M quantum number underneath each column. So for the S block, remember the box number for M for the S orbital is 0. M can go from negative L to positive L. Since we said there is no such thing as negative 0 or positive 0, the only mailbox numbers you'll ever have in the S block is 0. Let's go to the P block. Since L was 1, you number your mailboxes negative 1, 0, 1. Okay, we did that up here, negative 1, 0, 1. When you get to the halfway point, repeat your pattern because that's when the husbands come home. Negative 1, 0, 1. For the D block, we said L was 2. So you'll say negative 2, negative 1, 0, 1, 2. Negative 2, negative 1, 0, 1, and 2. Finally, for the F block, negative 3, negative 2, negative 1, 0, 1, 2, and 3. And now you repeat your pattern for the husbands. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. So without having to draw the boxes, you can actually count it out and figure out what their mailbox number is based on their position. So that's all the quantum numbers pattern, all in a nutshell. Okay, next video we're going to go over the answers to the homework, question number 20 on the Chapter 5 Review of the Notes worksheet.